Dear students, today we will learn isotopes and their uses. At first, what is isotope? Isotope you didn't learn in previous classes. It is totally new for you. What is isotope? The atoms of same element having same atomic number but different mass number are called isotopes of one another. That means same element, the atoms of same element, their atomic number must be same but their mass number are different. Then these atoms will be isotope of one another. In previous class, I gave a chart of some elements with their atomic number and mass number. There you saw that in chlorine atom, its mass number is 35 and 37. That means chlorine atom has two mass number, 35 and 37. Because their neutron numbers are different. For 35 mass number, chlorine atoms have 17 atomic number, that means 17 proton number, but there are 18 neutron. But for 37 mass number, chlorine atoms have 20 neutron. So for the variation of this neutron number, their mass number becomes different, and so they are isotope to one another. Dear students, in this way, not only chlorine, there are many atoms and they have variation on their mass number. For example, hydrogen. Hydrogen has three isotopes. We know that the mass number of hydrogen is 1, but there are very few hydrogen atoms. Its mass number is 2, and there are very rare hydrogen atoms that they have mass number 3. But most of the hydrogen atom they have mass number 1, so we can tell that the mass number of hydrogen is 1. In this way, chlorine has two isotopes, chlorine 35 and chlorine 37. Look, dear students, I have written the isotopes of hydrogen in this way and the isotopes of chlorine are in this way. But you can write any of them in any way. Just I have shown here some way to write isotopes. Here mass number you have to mention, atomic number you can or can't. Carbon has three isotopes. Here look, here I have shown only the mass number. Carbon 12, that means the mass number of carbon is 12 here, and some carbon atoms it may have mass number 13 and some have mass number 14. All they are carbon atom, so their atomic number is 6. Their atomic number is 6. They are same element but their mass numbers are different because of the difference on their neutron number. So they are isotope to one another. In this way, oxygen also has three isotopes. They are oxygen 16, oxygen 17 and oxygen 18. All they have atomic number 8 but their mass numbers are different. These are the examples of isotopes. There are also some other elements which have isotope, but in this class you will learn only the isotopes of these four elements: hydrogen, chlorine, carbon and oxygen. Now, isotopes of hydrogen. Already we learned this, that hydrogen has three isotopes: hydrogen 1, hydrogen 2 and hydrogen 3. The atomic number of hydrogen is 1, so it has 1 proton. We know this, and we know that hydrogen has mass number also 1 because hydrogen is the only one atom which has no neutron. 1 proton and no neutron, so the mass number of hydrogen is 1. But dear students, if we collect 1 lakh hydrogen atom, then we will get 99,995 hydrogen atoms which have one mass number. But 5 of them have 2 mass number 2. But the mass number of hydrogen is 3. It is very rare, and if we collect more hydrogen atoms, then we can get only one of this type. Look, these 3 isotopes of hydrogen, they have also separate name. This hydrogen atom, it has 1 proton and no neutron, so its name is protium. It has 1 proton and no neutron. Its name is protium. This hydrogen atom, it has 1 proton and 1 neutron. So its mass number is 2 and its name is deuterium. Its name is deuterium. And another isotope of hydrogen which has mass number 3 because it has 1 proton and 2 neutron, its name is tritium. So these 3 isotopes of hydrogen, first one is protium, it has 1 proton and 0 neutron. Second one is deuterium, it has 1 proton and 1 neutron. And third one, its name is tritium, it has 1 proton and 2 neutrons. Now, isotopes of carbon. Look, these 3 are the isotopes of carbon. Here, proton, these are colored in red color, and neutron, these are shown in by black color. For this carbon atom, there are 6 proton and 6 neutron. So it is carbon 12 isotope. Its mass number is 12. Here, it has 6 proton and 7 neutron. So its mass number is 13 because it has 7 neutrons. And in the same way, it has 8 neutrons. So its mass number is 14. So carbon has 3 isotopes and all of them have atomic number 6 because it has 6 protons. But 12 carbon, it has 6 neutrons. Carbon 13, it has 7 neutrons, and carbon 14, it has 8 neutrons. The proton number of carbon is always 6, but their neutron numbers are 6, 7, and 8. So we can tell that variation of this neutron number makes the mass number different. So this variation of neutron number is responsible for making isotopes. And for this why these 3 are isotopes to one another. In the same way, isotope of oxygen, these are isotope of oxygen. This is oxygen 16. It has 6 proton and 6 neutron. Oxygen 17 has oxygen 16 has 8 protons and 8 neutrons. Oxygen 17 has 8 protons and 9 neutrons, and oxygen 18 has 8 protons and 10 neutrons. So all these isotopes have 8 protons, but their mass number varies. Why? For the variation of their neutron numbers, because these isotopes have 8, 9 and 10 neutrons. Now, isotope of chlorine. These are 2 isotopes of chlorine. One has 17 proton and 18 neutrons, and another has 17 proton and 20 neutrons. Now, dear students, when we will read the atomic mass, then we will learn the atomic mass of other atoms. These are full digit, but the atomic mass of chlorine, it will be 35.5. Do you know why? Because these 2 isotopes of chlorine, they are available in nature. Other isotopes, I told, for hydrogen isotopes, most of the hydrogen atom are hydrogen 1. Like this way, other oxygen, carbon, these isotopes also. If we collect some atoms of these element, then we will get that most of them have the mass number of oxygen 16, carbon 12 in this way. But chlorine, if we collect 100 chlorine atoms, then we will see that 75 of them have 18 neutrons. That means their mass number is 35, but 25 has 20 neutrons. That means their mass number is 37. So availability of these two isotopes are in nature. So their atomic mass is counted by using their availability and mass number, which we will learn in standard 9. Now just you will remember that the percentage of these two atoms are 75% and 25%. 75% chlorine 35 and 25% chlorine 37. Chlorine 35 isotopes, it has 17 protons and 18 neutrons, and chlorine 37, it has 17 protons and 20 neutrons, and their availability is 75% and 25%. So their ratio will be 75 is to 25. It can be written 3 is to 1. Now, with isotope, another two terms will come. These are isobar and isotone. What is isobar? Isobar, these are the atoms of different element, obviously different element, because their atomic number is different. But why they are isobar? Because their mass number is same. That means the atoms of different element having same mass number are called isobars of one another. For example, look, these are two different atoms, nickel and copper. The the atomic number of nickel is 28 and the atomic number of copper is 29. But these two atoms, it has 36 neutrons, so its mass number is 64, and it has 35 neutrons, so its mass number is also 64. Dear students, this is not the available copper atom, because we know the mass number of copper atom is 65, but it is one of the isotope of copper atom whose mass number is similar to the mass number of this nickel atom, but their atomic number is different, so they are isobar to one another. Look, these are argon and potassium. We know that their mass number is same, both have 40. Argon and calcium, their mass number is same, both their mass number is 40. And one isotope of potassium, it has also mass number 40, but their atomic numbers are 18, 20 and 19. Their atomic numbers are different, so they are different element, but for having same mass number, they are isobar to one another. In the same way, carbon 14 and nitrogen 14, here their atomic number is different, they are different element, but their mass number is same, so they are isobar to one another. Copper 65 and zinc 65, their mass number is same, so they are isobar to one another. In the same way, there are many isobars where you will see that their mass numbers are same, but they are different element, and obviously their atomic number will be different. So these are called isobar to one another. Now another one, that is isotone. Isotone, here the atoms which come from different element, because their atomic number is different, but the amount of neutron is same for isotone. For isotone, their atomic number is different, their mass number is different. But what is same here? Here, the amount of neutron is same. Their neutron number is same for isotone. So they are isotone because their neutron number is same. Look, here phosphorus 31 and sulfur 32. Their atomic number 15 and 16, mass number 31 and 32. But here the neutron number of phosphorus is 16 and neutron number of sulfur is also 16. Here calcium and potassium, their atomic numbers are 20 and 19, mass numbers are 40 and 39, but their neutron numbers are 20 and here also 20. So they are isotone. In this way, there are many atoms where atomic numbers and mass numbers are different, but if you count neutron number, you will see that their neutron numbers are same. So they are isotone to one another. That means the atoms of different element having same number of neutron but different atomic number and mass number are called isotones to one another. Here there is another example, oxygen, nitrogen and carbon. Here for this oxygen there are 8 proton and their mass number is 16, so neutron is also 8. Here for nitrogen 15 and isotope of nitrogen 7 proton and neutron is 8. Carbon 14, isotope of carbon, here 6 proton and neutron is 8. All they have 8 neutrons, but their atomic numbers and mass numbers are different, so they are isotone to one another. So dear students, you will remember just for isotope, their atomic number is same but mass number is different. For isovar, their mass number is same but atomic number is different. And for isotone, their atomic number and mass number both are different but their neutron number is same. Now, radioactive isotope. The isotopes which can radiate different types of rays, not all the isotopes. Some isotopes which can radiate different types of rays. For example, alpha ray, beta ray, gamma ray. These are called radioactive isotopes. That means the isotopes which can radiate alpha ray, beta ray, gamma ray, these types of ray, these isotopes are called radioactive isotopes. And there are many uses of these radioactive isotopes. These radioactive isotopes are used in different fields. Radioactive isotopes have a variety of applications. Generally, however, they are useful because we can use the energy they release because they radiates the energy, different types of ray, and by using this energy, these radioactive isotopes can be used in different field. Some of the uses of radioactive isotopes are in medical sector, in agriculture, in food production, and also in geological research. So, uses of radioactive isotope in medical sector. How in medical sector radioactive isotopes are used? Isotopes are used in the diagnosis and treatment of diseases. Radioactive isotopes are used in the diagnosis of diseases and also in the treatment of diseases. For example, if there is any defect in the narrow artery, it can be detected by sending a radioactive isotope. Look this picture. Here, there is a blood clot in this artery. So here, a radioactive isotope can be sent through this artery to detect this clot. Again, the cancer-affected cell can be determined by sending radioactive isotopes. Cancer-affected cell can be determined, and radioactive isotope can be used to destroy the cancer-affected cells. So, in this way, isotopes can be used to diagnosis and to treatment of diseases. In this way, radioactive isotopes are injected in the blood and cancer cell can be determined by using radioactive isotopes. And the another use of radioactive isotope is radioactive isotopes are used to sterilize medical instruments. It is used to sterilize medical instruments. Now, uses of radioactive isotope in agriculture. Isotopes are used in agriculture also. For example, phosphorus 32. This isotope is used in agriculture by the following ways. The radiation from isotopes are used to control insects. The radiation, that means the ray that is emitted by this radioactive isotope, this ray can control insects. It can be used to find out what type of fertilizer and what amount of fertilizer is needed for a specific crop. By sending a radioactive isotope, we can determine the type of fertilizer and also the amount of fertilizer. Look, here on the root, phosphorus 32 is injected and there is a counter that is used for determining the growth of the plant and also the type and amount of fertilizer needed for this crop. Uses of radioactive isotope in food production. Radioactive isotopes are used to keep food and fruits remain safe. Germs and bacteria can be killed by the radiation from radioactive isotopes. So, they can be used to make food and fruits germ-free. The radiation that is radiated from the radioactive isotopes, they can kill the germs and bacteria of food materials and they can keep the food and fruits germ-free. Cobalt-60 isotope is used for preserving food materials. Here, gamma ray is emitted from cobalt-60 isotope and these gamma rays, they kill the bacteria. Uses of radioactive isotope in geological research. Radioactive isotopes are used to detect the age of fossil, mummy and many ancient things. In this way, radioactive isotope can be used to determine the age of many ancient things. For example, carbon-14 isotope is used to determine the age of mummy. So, dear students, today up to this. Goodbye everyone.